Challenge activity 3.3.3. We're going to use Excel to do regression to make predictions, which is, again, kind of the end game or the ultimate goal of linear regression. So you need to click the link to download the spreadsheet, and it does instruct you to use the data analysis tool pack. And I know I've talked to a few of you. I'm going to use it for the instructions today, but if you're having a hard time with the tool pack or haven't been able to download it, let me know and we'll go from there. We'll figure it out. A researcher is analyzing the relationship between various variables in housing data for 32 cities. Median list prices of single-family homes, condominiums, or co-ops, all homes, median household incomes, unemployment rate, and population. What is the regression equation for the model that predicts the list price of all homes using population as an explanatory variable? So I've already downloaded this spreadsheet, so I'm just going to show you right here. So we are looking at, it says to predict list price of all homes and population. So what we're going to do, if you guys haven't noticed yet, I'm big on creating new sheets because I like keeping things a little organized, so please don't mind me. I'm going to go ahead and copy this cities list just to have over here for reference. And I like to bring it all, it just helps me. So population is going to be our predictor. And household, what did it say? Household, no, not household income. It said listing price of all homes. So here we have single family, condos, and then all homes. So I'm going to, copy that over to this sheet. So now we've got this nice little spreadsheet here with just the variables we're concerned with. So what we first want to do is go ahead and come up with our regression line. So we're going to go to data, data analysis, regression. This is already populated because I was playing with it earlier, but I'm going to delete it all just to show you from the very beginning. So, let's do this. We're going to start here with our input Y range. So we see here, it's all homes, right? So we're going to select this all the way down. That needs to go up here. Sorry about that. Okay, there we go. Now we have C2 through C33 for our Y range. For our X range, we need to select population. And then you can put this anywhere. I tend to like putting it right here so I can see it next to my data. It's a good way to kind of visualize it and helps you go back and forth. So go ahead and click OK, and it went ahead and put all of our results here. So first thing we need to do is come up with, what does it say? Our equation. So first we need to get our slope. And that's where you go down here. X1 variable coefficient is your slope. And we need about 3 decimal places because that's what the example here tells us. Well, we'll assume. So we're going to do 0.047. 0.047. And then we're going to get our intercept. That comes from right here. So we have, let's go ahead and just copy that and paste that there. So we have $318,088 and about 8 cents. All right, so that's our regression equation. And then let's pick the interpretation of the slope. So our slope here is positive. So it says, what is the interpretation of the slope? Blank in the list price of all homes as populations increase. So we're looking right here for increase or decrease. If that was a negative number, it would be a decrease in the list of all home price as population increases. However, here we're looking at an increase because it's positive. Now, what is the interpretation of the intercept? So in this case, we're looking for what is the listing price when the population is 0? I don't know about you, but there's not a lot of cities with a population of 0. It wouldn't be really categorized in this data set. So it really doesn't make sense to interpret that because if there's no population, then there's nothing to analyze. So there's no practical interpretation. So let's check. Nice little green check mark saying we did it all correctly. Let's go to the next section. Here it says a researcher is analyzing the relationship between the that's the same description. So now we're looking at the coefficient of determination, that R squared. What is the coefficient of determination, R squared, for the model that predicts unemployment rate using population as an explanatory variable? So now we're looking at 2 different variables. Now we have unemployment rate using population as explanatory. So let's go back to our spreadsheet. We're going to go back to sheet 1. Oops. I'm not, here's my part of my problem is I'm recording it. So it's got this little button there that won't let me click over. All right, so we have unemployment rate and population. So let's go ahead and copy our city first. I just think that's, and again, some of this is more has to do with reporting also. You don't necessarily need the city name there for the work that you're doing. So if you don't want it, that's fine. My thing is, I like to do this as if I were doing it in a statistical analysis world, and I would definitely make sure to want to keep track of those cities. So it is kind of important. And then population is going to be our explanatory variable. Copy that over. Again, copying this over also isn't necessary. I just like it. It makes it easier for me personally to keep track of the different work I'm doing. All right, so we've got our stuff. Population is going to be, let's double check, is going to be the explanatory variable, and we're trying to predict unemployment. So let's go ahead and do our regression. Click on data. Remember, it's the data tab, data analysis link within there, and then regression. All right, and what it already selected was what we did for the last one, and it's exactly the same, but you can always double check it. So, it doesn't ever hurt to go ahead and double check, but here it says B2 to B33, which is what we need, and then it's got C2 through C33. You can always check it by doing this and go through and look at the different cells it's already selected. Here it's got the output range. We're going to go ahead and put our results right there. Click OK, and our nice little table. So it was looking for our R squared, and that's right here. So let's go ahead and copy and paste that. We might need to trim it down a little bit because it probably has way too many places. So let's just leave 3. Now that's going to round it up to 2. So we're going to put 0.42. And then the interpretation of this coefficient of determination in context is that blank % of the variance in unemployment rate is explained by the variance in the population. So in this case, we do need a few more of those decimal places. So let's do this. We're going to say it's 24 point, and we're going to delete all that percent. That's, again, it's just the percentage. So this is 24 point, this was 0.241666, and it went on. So now we're saying that's 24.166% of the variance in unemployment rate is explained by the variance in population. Let's check. There's our check mark saying that we did it correctly. So there's our R squared. And remember, those two numbers are correlated. So I guess we could have also put in 24.2, but I wasn't sure what the decimals, and I'd rather be safe than sorry. So in that situation, yes, you could have also put in 24.2. I would have rounded there. But you see they're correlated, right? Because that 0.242, you just multiply it by 100 to get that percentage. All right, that's a little bit more about that R squared coefficient. So if you have any questions about that or anything else, let me know.